The rapid progression of artificial intelligence is transforming medical research and healthcare.
Whether that's intelligent assistants, chatbots to help explain different healthcare concepts to you, or even healthcare robotics. AI is enabling all these various fields, and we're exploring all of them, trying to see what's possible right now and try to illuminate the path forward in the space.
Paving the way for even more transformative innovations on the horizon.
This could be surgical robots, imaging robots. This can even move into the dimension of fully automating wet labs for drug discovery.
Discover the progression and transformation of AI in medical research and healthcare inside this edition of CTSI Discovery Radio. Welcome to CTSI Discovery Radio. I'm your host, Brian Belmer. CTSI Discovery Radio is brought to you by the Clinical and Translational Science Institute of Southeast Wisconsin. The CTSI is a consortium of researchers, doctors, scientists, and others representing 8 institutions, including the Medical College of Wisconsin, Milwaukee School of Engineering, Marquette University, the University of Wisconsin-Milwaukee, Children's Wisconsin, Froedtert Hospital, Versity Blood Center of Wisconsin, and the Zablocki VA Medical Center. The CTSI works collaboratively across all of our member institutions. Our mission is advancing health through research and discovery. In the fall of 2025, the Southeast Wisconsin Data Science, or CWINS Collaborative, held its second annual symposium, where the theme was Artificial Intelligence Enabling Translational Science. The conference featured keynote presenter Nigel Nelson, an AI and machine learning engineer at NVIDIA, and an MSOE graduate. Nigel shared his insights on healthcare AI, including imitation learning for healthcare robotics and advances in vision language models. Now, because he presented to an auditorium full of data science and computer experts, it was pretty high-level stuff. But today, we have the opportunity to hear many of the same insights he shared then, as Nigel joins us to explain them in a way we can understand. Nigel first tells us who and what his employer, NVIDIA, is.
NVIDIA is a company that is built on the single belief that accelerated computing can solve problems that ordinary computing cannot.
He adds that NVIDIA is primarily known as a maker of graphics processing units, or GPUs.
The original intent for GPUs was for 3D graphics. If you can imagine, you're playing a video game and you move your joystick and you're looking around in your 3D world. In order to render that 3D world, for each one of those pixels on your screen, your game engine is having to compute the new geometries that are coming into view, the ones that are leaving, and then all of the lighting updates for each one of those pixels.
How is a GPU different from a CPU, or central processing unit, which is the brain of your personal computer?
A GPU and a CPU are similar in that they're both general purpose processors, but they have different strengths. CPUs are optimized for low latency sequential logic, and GPUs are optimized for massively parallel workloads.
And that is massively critical. For example, in the context of gaming,
unless you want extremely laggy, slow games, which most people do not. They want it all to happen seamlessly. And so that's where GPUs first came in, handling all of that very complex parallel computation of 3D rendering in games.
But today, there's another domain benefiting from the parallel computation of GPUs.
And that is AI, now what NVIDIA is primarily known for enabling. And so this is ultimately much of the realm that NVIDIA plays in. We don't just deliver GPUs anymore because it's much more than that. We deliver the full systems, the networking, software stacks, the AI factories.
Nigel characterizes them this way.
Because that's what they are now. It's no longer just these consumer graphics cards, even though that's something we still deliver. As far as the leading edge stuff that is enabling all this transformational AI, these are now full-on data centers where a GPU is no longer something you hold in your hand. It's a 3,000 pound, essentially file cabinet of just dense compute. That's ultimately what NVIDIA creates and delivers.
Perhaps the name NVIDIA is already familiar to you.
NVIDIA will be in a lot of laptops. For the gamers out there, these are the graphics cards in desktops that you can build yourself or you can buy off the shelf. Potentially one of the most recognizable devices out there would be the Nintendo Switch. That is powered by NVIDIA's GPUs.
To sum up NVIDIA,
we kind of bleed into the background. We oftentimes are not the final product. We're the product to the developers, and then people build on top of us.
Understanding that, how then is NVIDIA involved with and impacting medical research and healthcare?
Ultimately, we're enablers. We try to identify the main pain points as it relates to accelerated computing in the healthcare space. One of the primary ways that we do that is with our HoloScan platform. This is a full stack of software, hardware, and networking to enable AI in the healthcare space.
Being referred to as an enabler oftentimes has a negative connotation, but certainly not in NVIDIA's case.
One thing that we do very well is this whole accelerated computing thing. And so the idea is that we try to give this foundational layer that is going to be common across any medical application and deliver that as a solution so that if you're a startup, if you're a researcher, or already a large industry player, if you have an idea to deliver a healthcare AI model, you don't need to spend all of your time in developing a solution.
Because as an enabler, in a good sense,
we're kind of experts in this space. And so largely, again, we're playing as kind of this foundational layer, accelerating people who are trying to bring AI to the healthcare space.
As mentioned, Nigel returned to his alma mater, MSOE, as the keynote speaker of the recent CWINS Symposium. What was the aim of his presentation?
The aim of the presentation was inspiration, ultimately, to just share some of the cutting-edge work that we're doing in healthcare at NVIDIA that are ultimately just demonstrations. We're not a healthcare robotics company. We don't sell final solutions that then go into a clinical setting. Everything we do in the research space is just very inspirational to light the way for others to extend, adopt, and make use of what we demonstrate.
Nigel's idea was to
highlight some things that might be coming in the healthcare space, whether that's intelligent assistants, chatbots to help explain different healthcare concepts to you, or even healthcare robotics. AI is enabling all these various fields, and we're exploring all of them, trying to see what's possible right now and try to illuminate the path forward in the space.
But although his presentation was designed for data scientists and the like, it's important for people like you and I as well.
I didn't come from a healthcare background. I didn't go to medical school. Talks like this are ultimately what inspired me to get into this space. One thing that I wanted to convey is hopefully excitement. I'm very excited for the future of this space, and someone in the audience or a listener right now may not be in this space, but just hearing about the directions where this industry is headed hopefully excites people to join this movement and make it their life's mission like I have.
We asked Nigel to share some highlights from his presentation, but in terms we can understand. He begins by explaining forms of artificial intelligence in healthcare. First, perception AI, which Nigel says is
the AI that a lot of people will be familiar with. So as it pertains to the healthcare space, perception AI are classification models with a closed vocabulary in their answers that they can provide. And given an image, it predicts one of two outcomes, benign or malignant, or what tissue it might be looking at, what organ it might be looking at, but this very closed set of answers.
He further explains,
each one of these models ultimately answers one question, and it answers it in a finite set of ways. So that can be done at whole image level, which we call classification, or at the level of segmentation, which is at the pixel level. For every single pixel, it'll say what pixel belongs to what, whether it's this organ or that organ, this atomical structure, a tumor or not. This is what I refer to as perception AI.
Then, the next progression of artificial intelligence, generative AI.
This builds on perception AI because it can answer similar questions, but in a much more open vocabulary type of way, where perception was answering with kind of this closed set of yes or no answers. This opens the door to these open-ended answers like text generative models like ChatGPT that can provide the answer to you and now even provide the reasoning behind that.
An example of this progression would be,
with a radiology image and a classification model, you could get a single output for what the diagnosis is, and that's it. Now, a recent model and work that was put out by NVIDIA is a vision language model. It's ultimately a generative AI model that is able to reason and diagnose chest X-ray images. And it will give you its full reasoning trace explaining how it arrives at a final diagnosis.
Which is progress that is absolutely
transformational for adoption and trust. This is just research, but you can imagine this is going to allow doctors to trust the answers much more, because instead of just a black box that says this is my final answer, take it or leave it, instead something that reasons through and provides the full differential diagnosis of the different shadows it sees, what that might be, and then allow you to trace that full reasoning trace into the answer, which enables a much higher level of trust.
Continuing in following the progression, Nigel next presents his insights on agentic AI.
These are the same generative models architecture-wise, as far as what these neural networks look like and roughly how they're trained. But these are generative models that are so capable that they're now able to interact with their environment. And usually this is in a digital way where they have access to tools, and given a question, they then can go search the web for information, comb through databases, even take actions on your behalf.
Meaning they essentially act as agents.
In the healthcare space, this is exciting because this is how most every healthcare worker operates. Interconnected and long horizon planning.
So, for example,
a radiologist doesn't just look at your X-ray image in isolation, only paying attention to that image and make a final diagnosis. They're going to look at your electronic health records, look at what your history has been, and compare what they previously saw to what they're seeing now. They might talk to experts within their clinic.
Likewise, an agentic model that's expert in radiology
can refer that back to another generative model that's a generalist that can then make a tool call to look at a patient's health history and aggregate all of this information on a patient's behalf to give them the best possible answer, as opposed to all these systems operating siloed. They're now able to interact together and with the larger digital ecosystem to have much more context around these healthcare problems.
The fourth model in this progression, physical AI.
A step just beyond agentic AI. Agentic AI largely lives exclusively in the digital world and can take actions, but digital actions, where physical AI now adds this tier of being able to allow these systems to actually interact and move in the physical world.
Also transformational because
this is where we live. A lot of us spend time in the digital world nowadays, but ultimately where life happens is the physical world. So this enables a whole new application space for AI.
What are some examples of physical AI?
This could be surgical robots, imaging robots. This can even move into the dimension of fully automating wet labs for drug discovery, where you have AI in the real world going around in a laboratory running experiments for you so that you don't necessarily have to be there.
Is physical AI yet to come, or is it already a reality?
This is much more emerging right now. Agentic AI is still largely where the vast majority of things live right now as far as like what is cutting edge. And physical AI, there's some exceptional startups and industry players out there and academic research in the physical AI space. I do not think that this true form of physical AI is fully adopted, but that is where everything, I think, is heading.
And heading there rapidly.
Some of its progression from perception AI to generative AI has become relatively established, as funny as that is, because they're still extremely new. But agentic AI is where we are, and physical AI is where we're going.
Nigel's presentation also focused on visual language models, or VLMs. What's that?
A vision language model is a large language model with a set of eyes. The way that you create a large language model that can see is you'll train the two components separately. You'll have your large language model trained on a bunch of internet data, so it gets really good at understanding the text space.
Then, for the model's visual aspect,
you get a visual expert. Again, you're training on a lot of internet data, and the way that you train this vision model to understand the world is you get it to be very good at captioning. You train the model to look at an image and write a nice verbose caption, so it has this joint image and language understanding.
Once you have both, each expertly trained,
you Frankenstein the two together.
Wait, did he just say Frankenstein them? Cool.
And since they already have this shared understanding of the language space, you can then fuse them together and train them as a single system for a little bit longer, to the point where you end up with a generative AI model that can open-ended explain what it's seeing and viewing in the real world.
Which is a big deal. Because
now you can show these models almost any image in the healthcare space, whether it's surgical or traditional medical imaging modality, and it can say what it sees and it can explain to you what it sees and what it's thinking, which is completely transformational compared to a black box model that just gives you an answer and only the answer.
Nigel shares an example of a VLM that he proudly worked on at NVIDIA, involving
a surgical VLM where we train this model to understand specifically laparoscopic cholecystectomies, which is gallbladder removal. You know, some listeners might just be thinking, well, ChatGPT, why not just throw that in there? Why do you have to do a surgical VLM? Why can't you just use the big model already used for looking at PDFs?
Fair question. It's because such consumer AI models are trained on internet data.
And so relative to the amount of cat videos out there, there's not very much surgical data. So if you take one of these off-the-shelf models and you ask it to give you a detailed report of what it's seeing being done throughout a surgery, it's essentially just randomly throwing a dart at the board and gonna put out some medical terms that it's learned, but we found its accuracy to almost be a random guess.
Therefore, medical-specific visual language models have to be expertly trained.
And for the surgical one that we trained, we worked with surgeons to train a VLM on the various anatomies that are seen throughout a procedure, different phases of that surgery, and then also all of the tools that are being used throughout that surgery. This is just research. It's just to serve as inspiration for others and understand the recipe to get there.
Nigel and his NVIDIA team discovered viable workflows by building this VLM, including
a full report generation based off of the surgery, where during laparoscopic cholecystectomy, you have an endoscope giving the surgeon the ability to see what's happening and do his work, but you can record and feed that in real time to this VLM that we train and have it annotate second by second exactly what is being done, so that after the operation, you can have a system summarize everything and give the surgeon a first pass report on what happened throughout the surgery, so that they don't have to sit down and start from scratch.
Speaking of scratch, AI is only beginning to scratch the surface in medical research.
I'm extremely excited about the possibilities. That's why I do what I do. There's so much exciting work being done. It's hard to keep track of everything, honestly.
And if you want to learn more about AI, perhaps the best way is
learning from AI itself. That's one of the things that I really love about the latest models that are out there right now. If you're interested in some dimension, you can ask one of these AI models to explain it to you and just totally go down the rabbit hole. So I think ultimately one of the best resources to learn about AI is AI.
Following his keynote address at his alma mater, MSOE, we sat down with Nigel Nelson to learn more about him personally and his work at NVIDIA. But first, he shared an excellent summary of his presentation at the CWINS conference.
I was trying to kind of highlight the overall theme, which is artificial intelligence enabling translational science, through the lens of some of the projects that I worked on over the past couple of years, starting at MSOE and then moving to NVIDIA. Following this trajectory that we've been on, focused on perception models, registration models like I did at MSOE. And then from there, we moved into these generative AI models. And in my presentation, I talked about vision language models and kind of how those can be adapted more for the medical space, as there's not a lot of this healthcare specific data on the internet. And so by fine tuning them on these specific data sets, they do much better on things like surgical video, radiology, etc. And then we moved on to the agentic component, which is adding tool use to these models, allowing them to operate autonomously. And then from there, we talked about the final agentic dimension, which is giving them the agentic tools to move into the real world, and displayed one of our robotic ultrasound examples that we showed at NVIDIA's big yearly conference that they do in San Jose.
Events like this conference are essential towards the advancement of artificial intelligence, particularly in healthcare and in medical research.
Events like this are extremely important just to enable the kind of community that we see here today with MCW, CTSI, MSOE, and Marquette. It really takes a community to build these kind of next generations of AI systems, because each one of these domains is incredibly deep, and that to follow along with AI, it's a full-time job. I really have two jobs at NVIDIA. It's actually doing my day-to-day job and then keeping up with all the research that comes out. And then these medical professionals, they have their kind of domain expertise. So to have this intersection of AI translating into clinical outcomes, you really need these two parties working together. And so that's why I think these events are so important, is building this community for networking and people to begin to form these relationships so they can work together.
And in addition to education and collaboration, another key component is inspiration.
You know, myself, I didn't go to medical school. I was fortunate enough to have a great professor who had this relationship with MCW and pulled me in the direction of registration for MR images and histology, and kind of fell in love with the healthcare AI space. And so I think these events are really important, especially being on campuses like MSOE, to kind of show students that this is a viable path.
Nigel has high hopes that from this conference,
new projects hopefully are formed. I hope that students meet faculty members they can maybe work with, faculty members meet healthcare practitioners who can give them insight into their projects. I hope that there's this general exchange of knowledge between some of the groups representing AI and ML, and then also the healthcare professionals who bring their domain expertise. And as I mentioned before, I hope that this inspires some people. It's great to see MSOE classes are ongoing here in Dirks Hall. And I hope that some students walk by and just see some posters and get that bit of inspiration that, hey, this actually really interests me. I want to pursue this area.
His own experience has taken him from playing junior league hockey to studying at MSOE and now being part of the team at NVIDIA as an AI and machine learning engineer.
I characterize my path as being filled with luck and being surrounded by great people. I was lucky enough that MSOE was only an hour away from my home. And so when I was playing hockey and the MSOE hockey coach reached out to me to come to MSOE, it was a name that I recognized and knew that they had just built this great computer science hall that we're in, and knew that this was probably a good path. So lucky enough that I stumbled into getting into MSOE, and then also that I met a great professor who brought me down this healthcare AI path that ultimately allowed me to get to NVIDIA.
And now that he is at NVIDIA,
every day I'm surrounded by incredible people that challenge me, inspire me, and helped put me on a path that has had me at each one of these progressions of AI, not really through any of my own doing, but just people around me have been positioning me in the right place. So I got to take advantage of all of generative AI as it happened. Be right there as agentic AI was taking place, and now I'm doing robotics, and that's kind of my focus. Right place, right time. Very lucky and have some great people around me.
he says lucky, but he's being modest. Still, landing at NVIDIA following his undergraduate studies is something
incredibly special. Being back in the computer science hall brings me back to finals week, studying day to day. This computer science hall that we're in is really where I spent essentially all of my 4 years. And my life is entirely different than I really expected it to be. I didn't have an idea when I was a freshman doing intro to software design that I would be at NVIDIA at the forefront of AI.
The excitement hasn't worn off. Probably never will.
It honestly still hasn't worn off. Most days when I come to the headquarters, I do have to pinch myself and realize that this isn't a dream. This is just my life, and I work at one of the craziest companies out there.
Along with excitement, he approaches each day with the confidence he gained through his educational experience at MSOE.
MSOE really challenged me. It's a difficult school, but it's a difficult school with great faculty that are there, so it's not hard just for the sake of being hard. They really do prepare you for the real world. The biggest thing that they emphasize is just how to learn. So through the challenging projects, you're oftentimes in a position where you don't really know where to start, and you just have to figure it out. They give you the tools, and they give you the lessons on how to solve these problems yourself.
Which is how MSOE specifically prepared Nigel for his role with NVIDIA.
Getting to NVIDIA, that's what I come across all the time. We have these new projects and domains that I've never dealt in before. But it's not daunting because I did this for 4 years at MSOE, where I just know how to take the first step and how to incrementally make progress until we arrive at a solution.
He's passionate about finding such solutions through AI.
Initially, fell in love with computer science, but then freshman year at MSOE, we had an intro to AI course where I trained my first image classifier, and I was just blown away that I didn't have to write any of the code. I just had to give examples, and the code itself learned. So that was when I first fell in love with AI.
And today, he's even more driven to find solutions specifically related to AI in medical research and healthcare.
I was a hockey player my entire life, so athletics was always at the forefront of my adolescent life. I've always been interested in health and wellness, and interested in how sleeping impacted performance, how diet did that, wearables, trackers, all of that. And early on, I got pretty interested in these things, listening to podcasts. Once you start with performance, you very quickly go to, well, how does sleep impact athletes? How does sleep impact dementia? And just, I had a natural interest in this space.
So, when one of his professors facilitated some undergraduate research at the Medical College of Wisconsin,
I was very intrigued. I did it, and even more so fell in love with the space. And then from there, when the healthcare team at NVIDIA had an offer for me, I was extremely excited to continue to pursue this love that I had.
That pursuit for Nigel continues at NVIDIA. And if you might be considering a career in the AI field, he encourages you to
go for it. It can be very daunting, but coming from someone who just has their undergrad in computer science, it's all very achievable. We live in an incredible day and age where all this information freely exists there online. I would encourage people to just take action, and if they have an interest, find a project that they care about and just figure out how to solve it. You're not going to know how to do everything off the hop, but that's kind of the point. Solve it as you work through it.
We've worked through and now reached the end for this edition of CTSI Discovery Radio. Special thanks to today's guest, Nigel Nelson from NVIDIA. I hope you've discovered something by listening, and I'm doubly hopeful you'll join us again next time. CTSI Discovery Radio airs the third Friday of every month. Make an appointment on your calendar and join us for each episode. On behalf of the Clinical and Translational Science Institute of Southeast Wisconsin and all of our affiliate partners and members, I'm Brian Belmer, wishing you happier, healthier days ahead. For more information about research or to listen to the podcast of this or any of our shows on demand, please visit our website at ctsi.mcw.edu. CTSI Discovery Radio is written, produced, and hosted by Brian Belmer in collaboration with WMSE Radio. The CTSI and this program are under the direction of Dr. Julie Freed.